going to go ahead and go through calculation of the measures of central tendency using a frequency distribution. And as you can see here, we have the number of children in the United States, in the US, and we have here is the potential scores, or the potential number of children, and here's the frequencies. So this would be a frequency table that we're going to use. But first of all, let's just talk about what are measures of central tendency. So we know that the measures of central tendency include the mean, median, and mode. Okay? So we need to make sure that we know whether this is a sample or a population before we do anything, because we need to make sure we're using the right notations. And in this case, I'm going to verbally tell you this is a sample, but typically when you're looking at data, I'll have somewhere in the scenario whether it's a sample or a population. You just need to keep your eyes open to determine whether you're working with a sample or a population of data. So let's move forward and we'll work on the mean first. I always report the mean first because it is the primary measure of central tendency. Next, I always report the median because that's a secondary typically. And then last, I report the mode. So we'll work on the mean first. So in your active engagement activity, when you're asked to report the measures of central tendency, you should be reporting the mean first, then the median, and then the mode. Just when you're reporting all three of them. So let's look at calculating the mean first. So since this is a sample, and I'll put of sample, our notation is a capital M, and we're going to use the equation, the sum of x over lowercase n. That's our equation. Now, to get this sum of x, we actually are going to need to do the sum of the frequency times x, because if we were just to add up these x values, 5 plus 4 plus 3 plus 2 plus 1 plus 0, that would just give us that adding all those numbers together, but it doesn't account for how many of each of those numbers there are. So we need to actually make sure that we're accounting for that. So to be able to do the sum of the frequency times x, I'm just basically going to add a column over here and call it my x times f. It doesn't matter which order, f or x, you're multiplying this times this. So 5 times 1 is 5, 2 times 4 is 8, 3 times 4 is 12, 2 times 6 is 12, 1 times 3 is 3, and 0 times 2 is 0. So what I do is I'm going to add those up. So in my calculator, because that will give me, if I add those up, it's going to give me the sum of f times x, or x times f, whichever you prefer. So 5 plus 8 plus 12 plus 12 plus 3 plus 0. See, and that's where you need to be careful, because there were 2 people that reported no children. So we need to make sure that we are accounting for that. So that means our, and I'm going to put here, m equals 40. We're going to replace the sum of x with 40 divided by, now we need to find our n, which is the sample size. So what we do is we add up that frequency column. So this column right here, if we add this, it's going to give us our sample size. So 1 plus 2 plus 4 plus 6 plus 3 plus 2. And that's 18. So our sample size is 18. Okay? So now we can just do 40 divided by 18, and that gives us 2.222 repeating. Because we need to report everything to the second decimal, the appropriate way to report this is m equals 2.22. This would be my final answer that you would need for the mean of this sample. So the mean number of children in the U.S. families from this sample is 2.22. If you'll notice, this is the second decimal, the tenths place, and because this was a 2 over here, we just keep it at 2. If it was a 5 or greater, that would have been a 3. It would have been 2.23. So you need to round appropriately. Okay, so the next thing we're going to do is find the median. Now, our mean is 2.22, correct? And the mean is 2.22. I'm trying to get us back to the original. We can see the original data. And so if I was to, let's say, draw a little, so we have 0, 1, 2, 3, 4, 5 as an x-axis. And then let's say I have a y-axis and I have 0, 1, 2, 3, 4, 5, 6, okay? And I'm going to run into my mean, but that's okay because we're getting the idea. So is what we're going to be looking at is, okay, for 0, 2 people scored 0, okay? For 1, 3 people scored 1. Okay. For 2, 6 people scored 2. Here's our bar for that. And then for 3, 4 people scored 2. And then for the number 4, 2 people scored. And then for 5 children, only 1 person had 5 children. So as you can see, the majority of the data falls kind of at this lower end over here, right? The majority of the data falls at the lower end, meaning it's skewing away from the positive side, the higher numbers. So it's considered a positive skewed distribution. Median, let's go to the next phase. So we're going to use the median. And it doesn't matter, this is done the same way, there's no real notation for it, so you just type out the word median. And to find the placement, so the placement of the middle number, you're going to use its sample size, right, plus 1 divided by 2. So what that does is find the exact position in the middle that you would count. So in this case, it's going to be 18, because remember our sample size is 18, plus 1 divided by 2. And I'm going to put the equal sign over here. So 19 divided by 2 is 9.5. So this is how many numbers you're going to count up. Now, a big mistake students often make is just writing the answer as median equals 9.5. But if you'll notice, no one scored 9.5. So that doesn't really make a lot of sense. So you have to go, oh yeah, that's right, I need to count that many. Now there's a couple different ways we can do this. We can go old school and we can write the numbers out. So like lowest to highest. So we have, 2 zeros, 3 ones, 6 twos. But this is to me, that is a long way of doing everything. So I'm going to talk about a shortcut. You can do that and then count 9.5 over. But I have a way that you can use this frequency table to find the median in a much quicker manner. So what I'm going to do is use the frequencies. So if I go 2 plus 3, that's 5, right? If I go plus 6, so I'm going to highlight here. 2 plus 3 is 5. And then if I add 6 to that is 11. So that's 11 counting up from the lowest to the highest. So that means if the third number up is a 1, that means at 9.5 is going to be 2. It'll be 2 next to each other, basically. At 9.5, you'll fall right in between. But if you take the average of that, it's going to be 2. So it's just a matter of counting up. They're already organized in order for you. So you don't have to do all of the rewriting of everything. So in this case, our median equals 2. Now, when it's a whole number, I'll accept you writing it as a whole number like that, or I'm okay with, since how we're doing 2 decimals, you can get in the habit of using 2 decimals, 2.00. Either way is perfectly fine with me. But it has to either be a whole number or 2 decimals. So here would be the answer. Either one of those would be acceptable for the median. The next, as you know, median is 2. So when we're reporting measures of central tendency, we often will be asked things like, well, which measure would be the best measure of central tendency? Well, because you only have a range of numbers between 0 and 5, I can look at this and go, well, the median is 2. If I want to know the easiest one, and again, mode does not have a notation, so it's really just the most frequent. The most frequently found. So if we look, 6 is the highest frequency, and that is for the number 2. So our mode equals 6. Now, a big mistake I see students making, see, that's the mistake I see people making right there, what I just wrote. The problem was I was thinking about talking about the mistake students make, and then I made the mistake. So that is the common mistake, is to write down the frequency instead of the actual number. So we need to make sure that we're writing down the raw score and not the frequency. So the mode should be 2. And it could be either 2 as a whole number or 2.00 with that second decimal. I'll accept either one of those since how it's a whole number. Now, if you look at, what would be the best measure of central tendency to report I can observationally look at it, or I can also mathematically look at it. So if I want to do this mathematically, is what I'm going to do is take the mean, and then I'm going to subtract the median from it. Okay? So if you remember, the mean equaled 2.22, and the median equaled 2. So if you'll look, the difference is a positive number of 0.22. This suggests that the data isn't normal, that it's skewed slightly. And it's suggesting a positive skew. So because of the fact that this is a positive number. Now, one other way we can kind of find out whether it truly is a positive skew is observationally. So this is mathematically describing our distribution, how it looks, and this is questions you might be asked. And then when we look, basically, I'm going to go through, I'm sorry. So we had our mathematical, and now we're going to describe this. Number of children, if I could spell it, shows a positive skew observationally as data piles on low end with tail to the right. So I always say the tail, the smaller end to right. This is confirmed mathematically and I'm just going to put math as subtracting the median from mean is a positive number. And that's how you write about a description of the data if you're asked to do that, which you will be in your lab and on your exam. So I just went through central tendency as well as how to describe using central tendency and to describe a distribution using central tendency. Hopefully that helps with your active engagement as well as your exam in the upcoming future.